This video is on solving linear equation word problems. So what that means is we're going to have a word problem. We need to convert it into a linear equation and then solve the equation to answer the problem. So here's two examples. We're going to start off in this video with just some straightforward examples, and the second video will take you into slightly harder examples. The sum of twice a number plus 13 is 75. Find the number. So usually when I'm solving an equation, solving a word problem, involving equations, you need to have something called a let statement. And the let statement defines the pronumeral in the question. So when I'm trying to work out what should my let statement be, it is usually go straight to the question, and that'll help you. So it says here, find the number, and straight away I know that my let statement or my pronumeral must be that number. So I'm going to say, let the number be n. So that means my equation will contain a pronumeral called n. Now it says the sum of twice a number. Well, twice something means to double it or multiply by 2. So I'm going to write that as 2n. And this word sum in mathematics means to add. So the sum of twice a number and 13 means will be equal to 75. Find the number. So this is a fairly straightforward question. All I have to do is find n. So I'm going to solve this equation first by subtracting 13 from both sides. So that gives me 62, and then I will divide by 2, and that will give me 31. And so to answer the question, it says find the number. Well, a word problem, I always give a word answer. So I will just say the number is 31. Nice and short, okay? It's always a good idea to check that your answer is actually correct. So I'm going to take this number, which is 31, and it says the sum of twice a number. Well, I'll do twice 31, means 2 of them, and 13. So the sum of twice this number, 31 and 13, it should give me 75. Let's check that. 1, 1, and 3 will give me 5 1s. 2 3s and 1 will give me 7. So yes, it is true. So I verified my answer actually works. All right, number 2. A park is 5 meters longer than it is wide. As soon as I read that first sentence, I straight away realize I've got no diagram. And if you can draw a diagram and the question is requiring you to visualize it, you should draw a diagram. So this question could do with some work. Let's change that so it's clearer. I'm making some big assumptions here. But I will tell you now this is a rectangular park. So a rectangular park is 5 meters longer than it is wide. Find the dimensions of the park. So like I said before, your let statement is going to be in what you're asked to find. Now, the dimensions is referring to the length and the width of the park. So that's 2 different pronumerals. So I've got a bit of a problem there in that I don't want 2 pronumerals in my equation. I only want 1. But then I've been given this other piece of information, which is the park is 5 meters longer than it is wide. So what I'm going to do is I'm going to let the park be W wide, and if it's 5 meters longer than it is wide, then the length must be W plus 5, because that's the 5 meters longer. So my let statement will be let the width of the park be W meters. And now we are told what's the one fact I haven't used. So I've used this little information now. The fact that I haven't used is the perimeter of the park is 90 meters. And a perimeter can be found by traveling all the way around the outside of the rectangular park. And so to find the perimeter, I'm going to add all the 4 dimensions of the park together. So I'm not sure if that showed up very well. I'm going to highlight all the way around the park to represent that distance we're about to find. So if I was to start here in this corner, I would walk W plus 5. And that would take me to here. Then I would walk W to get to the next corner. Then I would walk another W plus 5 to get to this corner. And then I would walk finally a distance of W to go back to where I've started. So that's that entire green length. And in the question I was told that it was 90 meters. I don't need to put units in the equation. So I can see I've got these like terms. all on the left-hand side of the equation. So I'm going to collect the w's together, giving me 4w plus, and then I will collect the 2 plus 5s, giving me 10. So I know that 4w plus 10 equals 90. Now I'm going to subtract the 10, which gives me 4w equals 80, and I will divide by 4, which gives me w equals 20. And this is where your let statement comes in. Once you finish the equation, you might actually forget, well, what on earth is this w? What is it finding? Well, if I go back to my let statement, the let statement says let the width of the park be w meters. So the question, so now I know that the width of the park here, the w, that represents this distance here, which is 20 meters. And if I go and look at the other dimension, that's 5 more, so that would have to be 25 meters. So as I said before, a word problem requires a word answer, so we just need a quick little answer at the bottom. I've run out of room, so I'll fit it over here. So the dimensions of the park are 20 meters by 25 meters. All right, I hope this video makes sense as to simple word problems. I think both of these would fall in the basic category. Our next video, we will look at solving equation word problems that are more complex.